In the previous video, we configured the drive to manually control the spindle from the drive's keypad, and we added a switch to tell the drive to accept commands from the CNC instead of the keypad. By the end of this video, we'll be able to control the drive remotely from the CNC using ModBus RTU over an RS485 network. This is everything you need to do to get an AltMill CNC router using the SLB EXT controller to communicate with a Durapulse GS20 series drive. If you're already familiar with how to do all this stuff and just needed a list of what to do, take a screenshot of this slide and this schematic, stop the video, and go do it. Now, most of this wiring was done in the previous video. All we'll be doing in this video is adding an RS485 cable. For everyone else, stick around. I'll walk you through all of these steps and share some insights and tips so you can get the most out of your AltMill CNC router with a Durapulse GS20 series drive. Here we go. Now, if you haven't done so already, turn on the drive, wait for it to tell us it's ready, and then power up the CNC. And don't forget to reset the AltMill Z-stop. There's a separate video showing you how to set up that drive ready indicator. It's quick and easy and a really handy feature to have. Go ahead and switch to CNC control of the drive and leave it there for the rest of the video. This switch allows me to turn the dust collector on, off, or automatically turn on whenever the spindle is enabled. This video shows you how to do that. The GS20 drive makes that super easy too. All the parts I used in this control panel are in the description below. We're going to start with the drive and do all this stuff, then do the AltMill side, do a test run or two, and cover some loose ends. The good news is we're going to set up the drive to use all of the AltMill default settings. So all we have to do on the AltMill side of this chart is enable the drive. CNC Labs has done all the hard stuff for us, so we can ignore all of this. We'll go over all this stuff in detail in a separate video about how to set up your own custom VFD. So watch that video if you want to get a peek behind the curtain or want to learn how to configure your own custom drive. If nothing else, it'll give you some appreciation for how much work CNC Labs did for you with the pre-configured drive settings in gSender. Timestamps to each item on this list are included in the video's description if you just want to jump directly to a single topic. Here we go. The terms drive, VFD, and variable frequency drive all mean the same thing and will be used interchangeably in this video. Now, before we get started, why would we want to control the drive via ModBus RTU instead of the easier PWM method? Because with ModBus RTU, the CNC controller can tell the drive exactly what speed it needs to be at, and it can ask the drive via ModBus what the spindle is currently doing. With PWM, the controller can't specify the exact speed, it can only get close, and it can't ask the drive what the spindle's doing. So if you want reliable, predictable control over your drive, it's definitely worthwhile to take a few minutes to learn how to control the drive via ModBus RTU. The bad news is, it's a bit intimidating because there's a whole bunch of things you have to take into account, as you saw in the opening slide. And if things aren't set up correctly, it won't work. The good news is, you now have this video that walks you through exactly how to do it right every time. Again, we'll configure the drive first using all of the AltMill defaults, and then we'll use gSender to simply enable the Durapulse GS20 drive. Okay, let's configure the drive. In the previous video, we added a switch to tell the drive to accept commands remotely from the CNC instead of from the keypad. But we never told the drive how to accept the commands. The drive can accept commands in multiple ways: Ethernet, ModBus RTU, analog, etc. So we need to tell it we'll be using ModBus RTU for remote control of both the spindle speed and the run-stop commands. Let's go to that page in the manual, and we see parameter 0.20 chooses the spindle frequency or speed control method in remote mode. We want the frequency to be controlled by RS485, so we enter a 1 into parameter 0.20. Parameter 0.21 is the remote operation for the run-stop commands. We want those also to come from RS485, so we need to enter a 2 for that parameter. The local control defaults to the keypad, so we don't need to mess with it, but if you want to check it, these are the parameters and the values you should see there. Now we need to tell the drive how the AltMil formats the messages. Parameter 9.0 is the drive's address on the RS485 network. gSender uses a default address of 2, so we'll use that. Parameter 9.01 is the baud rate. gSender defaults to 19.2K baud, so we'll use that. Parameter 9.02 tells the drive how to react when there's a communication fault. I'm going to say don't do anything. You can also ramp to a stop, or issue a warning and continue on. Your choice. Parameter 9.04 is the key one everyone stumbles over. For each byte sent, gSender uses 8 bits of data, no parity, and 1 stop bit when communicating with the drive. We abbreviate that as 8N1. I connected a scope and verified that. Yep, 1 start bit, 8 data bits, 1 stop bit. And that repeats. 1 start bit, 8 data bits, 1 stop bit for every byte in the message sent. Now this is the part that trips everyone up. If I go to the GS20 user manual, parameter 9.04, and scan down the list of possible protocols, sure enough, there it is, 8N1. So we want to enter a 6 for parameter 9.04, right? No. This does say 8N1, but it also says to interpret the data as ASCII characters. We're not using ASCII. We're using ModBus RTU, which is down here. So you need to enter a 12 in parameter 9.04. I'm embarrassed to admit that it took me the better part of a week to figure that out. Next, we need to wire the drive for ModBus RTU. Now, almost everyone struggles with this because while some manufacturers follow the RS485 standard, most don't. And it's left to you to figure out which one your system's using. So let's try and understand this so we can make the right choice. It's important to understand that RS485 takes a series of digital pulses and sends 2 copies down the wires. One is an exact copy of your digital pulses, and one is an inverted copy. The idea being that any noise that gets onto one line will also get onto the other. So the receiver simply subtracts the 2 signals. The noise cancels, and since one of the signals was inverted, the signal doubles. I grabbed a scope trace of my AltMil's RS485. This is the plus signal, this is the inverted or minus signal, and this is the difference between the 2 signals. Look how much noise that simple subtraction eliminates. That's called common mode noise rejection. It's rejecting noise that's common to both wires. Because of that, RS485 can reliably communicate well over 1,200 meters, or roughly 4,000 feet. Yeah, it's pretty incredible how reliable RS485 is. The main thing to remember is there's a positive wire and an inverted or minus wire, and you always connect the positive to the positive and the minus to the minus. If you add more devices, the same rules apply. The AltMil gives us 2 ways to wire RS485. This 6-pin RJ connector, or you can use this green EuroBlock or Phoenix connector if you prefer discrete wiring. Now, according to the schematic, pin 3 on the RJ connector is the minus or B signal, and pin 4 is the plus or A signal. Keep in mind, the RJ connector is labeled like this, so pin 3 is physically below pin 4. You can get pre-made cables from Amazon, or just get one from an old thrift store phone. It might have 2 pins populated, 4 pins populated, or even all 6 pins. Just make sure that the center 2 pins are wired. Those are the only 2 you need for RS485 on this board. If you want to use the green EuroBlock connector, you only need the A and the B signals. A is plus and B is minus. Which is common practice, just beware that the actual RS485 spec says A is the minus and B is the plus. So you have to be real careful when setting up your RS485 system and know that these inconsistencies just confuse everything. I did a continuity test between the green connector and the RJ connector to verify that. If I orient the cable's RJ connector like it's going into the AltMil controller and zoom in, I can see the wire colors. In particular, the plus wire on pin 4 is green, and the minus wire on pin 3 is red. Now we go over to the GS20 drive and connect the plus wire, the green wire, to the plus terminal, and the red or minus wire to the minus terminal. Again, in RS485, you always connect plus to plus and minus to minus. To remove a wire, just press this release button and pull. I like using these little ferrules to ensure a better connection, and it makes installation into these clamping connectors easy. You just shove them in. These clamping connectors are another feature I really like about this drive. RS485 requires that you terminate the network with a resistor that matches the impedance of the cable at both the start and the end of the network. That's so energy doesn't get reflected back to the source and distort the waveform. The GS20 doesn't have a built-in resistor, so in theory, you're supposed to add a resistor here between the plus and the minus RS485 signals. 120 ohms is the standard value that will get you really close without having to do any impedance measurements. The AltMil controller does have a built-in termination resistor, so we're good to go there. Now, do you really need to add a termination resistor? No, not really. Why? Because termination resistors really don't do anything until the cable length is more than 20 to 30 meters in length. So if you don't have a 120 ohm resistor laying around, try it without the resistor. I've run my AltMil for a long time with no resistor and have had no issues at all because my drive is only 12 inches from the controller. If you do have access to a 120 ohm resistor, well, go ahead and add it. With that resistor installed, you'll know you did everything you could to eliminate noise. Notice that the drive has a communications ground terminal. You don't want to use that here. It'll just create a potential ground loop that screws everything up. RS485 doesn't need a ground reference because we're comparing the signals to each other, not a ground reference. Well, that's it. We're now wired correctly and the drive is ready to go. We're finished with all of this, and now we're going to work our way down this side. And again, the good news is CNC Labs has already done all the hard stuff for us. All we have to do is bring up gSender, go to Config, and Spindle Laser to select the GS20 drive. Uh-oh, wait a minute. We have no options. What's going on here? Because I was trying to do this before I got my AltMil, it took me days to figure out you have to be connected to the AltMil to see what options the AltMil has. Duh. So, I'll connect to the AltMil, and voila. Now we have all kinds of options for our drive and spindle. By the way, I'm using gSender version 1.5.7 for this video. I like to enable this so I can manually control the spindle from the main carving screen. Apply that, go back to the main screen, and sure enough, down here we can manually control the spindle. We're not ready to do that yet, so let's go back to Settings, Spindle. Now anything highlighted in yellow, like this guy, is stuff we've changed from the default settings. We want the normal CNC function, not a laser or a lathe, so that default works. The on delay is used by the RS485 control method to decide if the spindle is working or not. The AltMil pulls the drive for spindle speed via RS485. If the spindle hasn't come up to speed within this amount of time, you'll get an alarm 14. That's another advantage of using RS485 for VFD control. The controller always knows what the spindle's doing. We'll leave this at the default, which is usually more than enough time to get the spindle up to speed. Now I don't have torque curves for this inexpensive spindle I got on Amazon, but usually a 2.2 kilowatt spindle's torque falls off rapidly at speeds below 6,000 to 8,000 RPM. This min speed just tells the controller not to allow speeds below this number. Set this to whatever you want, just know that the spindles are not designed to run at low speeds. At low speeds, the spindle will draw a lot more current and will be more likely to burn up if you push it too hard. We'll leave ours at the default 7,500 RPM. Max speed. We know this spindle's 24,000 RPM, so this default works. This version of gSender defaults to the CNC Labs VFD, which doesn't use RS485. How do we know it's not using RS485? Easy. If you look at the SLB controller, there are two LEDs right about here. The bottom one is green, and it blinks each time the AltMil sends a command to the drive. The top one is red, and it'll blink each time the drive sends a message to the AltMil. No blinky lights means no RS485. I'll switch to the Durapulse GS20 Drive and hit Apply, And look at that. We now see the RS485 LED status lights telling us the RS485 messages are going to and coming from the drive. The LED's blink duration is too fast for the video to capture it cleanly, but when you see it in real life, it'll be very clear that the AltMil is sending the green messages and receiving the red ones. The documentation says to power cycle the SLB controller to get this to work, but clearly it's working, so I've never cycled the power at this point and have had no issues. If you're worried about it, go ahead and cycle the power. If I unplug the RS485 cable, we see the green LED blinking, telling us the AltMil is sending commands to the drive. But there's no blinking red LED, which tells us the drive is not replying. Plug the cable back in, and now we do see the red LED telling us the drive is replying. So if you only see the green LED messages going to the drive, then the drive isn't replying, and either the RS485 wiring is backwards or something is goofy with the parameters. Try swapping the RS485 wires first. That's easy. Just swap these two wires. You don't even need to power the drive down to do it. Just be careful you don't touch any power lines. If that doesn't work, switch the wiring back and take a close look at the gSender configuration. The only thing you should have changed was the drive selection. Sienci Labs did all the heavy lifting for us. Also, check the drive communication settings and make sure they match the gSender defaults, which you see here. Since we do have both of the RS485 LEDs blinking, let's do a quick test. I'll go back to the main screen and select that Spindle control tab we enabled earlier. We see the default drive is now the Durapulse GS20. Perfect. Tell it to run in a forward direction at the minimum 7500 RPM, which was the default in the gSender spindle setup we saw a minute ago. If I bring up my tachometer, yep, the spindle's running at roughly 7500 RPM. Crank up the speed, and it tracks. Perfect. When I stop the spindle, we see the spindle's definitely rotating in the correct direction. Again, if it's rotating backwards, then with the drive completely powered off, this is where that drive status light comes in really handy. Give it a second. There we go. Simply swap any two of the 3 spindle power wires at the drive. Swapping any 2 wires will flip the rotation direction. I'm going to reapply power to the drive and get things back up and running. Well, we're done. Everything's working as expected. Remember, we were able to skip all the nasty configuration items over here because we told the drive to use all of the gSender defaults, and Sienci Labs did all the heavy lifting for us. Now, if you're curious about the configuration items we didn't touch on, or want to learn how ModBus messages are formatted, and or learn how to interpret the actual digital data on the RS485 wires, then check out this video where we configure a custom drive for RS485 comms, and get really deep into that stuff. Now, you don't need any of that to have fun with your AltMil CNC router. That video is for the person that wants to add their own custom drive and or the hardware geek that just wants to understand how all this stuff works. It'll also be helpful to anyone that wants to debug the RS485 link. And one side note, Automation Direct has several videos showing you how to use the free software they provide for the GS20 series drives. I'll put a link in the description below to that software. If you're going to be messing around with your GS20 drive, I want to encourage you to give it a try. It makes parameter management and backup super easy, and it even has an O-scope feature that allows you to see what's going on inside the drive in real time. We'll be using that a lot in the braking video. Okay, that's enough. Go play with your CNC.